Thank you all, thank you all. Shermy started 2007, and we grew quickly. We utilized GIS and the telemetry solutions to solve efficiency and productivity. Productivity was targeted at government agencies, efficiency at large organizations. And we quickly realized we have a big problem. Because of our solutions we offered, our data was growing very, very quickly, and we would not have had the resources to grow servers quickly in respect to, and still offer a very good uptime in terms of telemetry. And this is where the big data issue came on. So we have environmental monitoring solutions that does continuous monitoring. We have GPS solutions that offer tracking and certain vehicle diagnostics, and we realized that we're actually adding 2 gigs of data in just 2009 AD. And we had to do something about it, but still be very cost effective. And that's where we realized with GIS, your data is going to grow quickly. It's going to be temporal. It's changing with time. If you do not analyze it quickly enough, then some important facts get buried in the past. And that's where we sought to use big data technologies such as Hadoop, PostgreSQL, to be able to go on. And what we did is, this presentation will give you just a few highlights of some of the technologies we use and how we think it. In terms of public health, the chronic disease program, which is the CDAP program, we are able to, based on treatment, so let's say, for example, metformin or insulin, tell where you have particular disease affecting the population. So metformin may be linked to diabetes. And how we made that relation is by using reverse and geocoding technologies and geocoding technologies. So we take an address, a street address, and automatically convert it into a latitude and longitude. And do that very, very quickly. We need to be able to do that at least in 1 second. We need to be able to do 600 of those based on our data set. And we are able to do that using open data sets, OpenStreets. OpenStreets has streets polls. We contribute also to the OpenStreet data set on a daily basis to increase the accuracy. In the previous presentation, someone said police and what police is doing. Police is making a very good attempt at GIS, I must say. It could be better. There's a lot of room for improvement. But there is hotspots policing that is being used. And it is a large-scale sort of pilot project in collaboration with the University of Cambridge. And this is where geozones are set for each hotspot. And with our GPS units in the vehicles, you are able to say how long that the police vehicle spend in that hotspot. Then it becomes sort of a very competitive thing between departments or between command posts to say who spend the longest amount of time in a hotspot. And what that does is you have a reduction of crime because it's compared with some crime stats. And to be able to do that, you need to be able to process a lot of data. Well, I did an estimate it's with 2 gigs of data per day on the location of these vehicles and some other business rules to be able to determine how much points each station is getting. Just another application of big data technology. We use it in transportation and logistics. So, and we like to say it's more than just the location. A lot of companies focus just on the location of the vehicles, but here are some things we do. We do timesheet validation using GIS. So the guy has to say his timesheet needs to match when he actually either entered the vehicle or when he reached the compound of the customer. We do, for health and safety requirements, we do things like speed. Now, speeding, you could say, all of us at some point in time will go for the speed limit. And this is a lot of data coming in, which is not too very meaningful. We take that data and we analyze it over a journey, and then send a trigger based on that journey. So for example, I could give you an example. Paramount, in order to meet their snow certification for safety, we would have looked at a specific time, real time, and then say this guy is constantly above an average of 90 kilometers per hour. For the last 2 minutes, health and safety should have a conversation with him. And the rule engine will automatically send an email or notification or whatever they determine they would want that notification. Improving of the mobile workforce is another application we use, and that is to be customers map out their geozones. And you will be surprised the amount of detail, how important it is for businesses to have someone either in sales or distribution sit down and map out the customers. Service companies do it in AC, food, in terms of flour mills. They map out their locations. And why this is important is it tells them when they visited, how long they visited, which customers were missed, which customers, in the case of Ramco and gas, which customers ordered gas, which customers may be due for gas, so where the vehicle has to route to based on it. So this is one of the ways we use GPS and logistics. In the offshore, onshore, we combine it with an RFID technology that gives us the coordinates and tells us, in a container bin, what are the items that are located in that bin and what is the location. So it might be on a platform, TIC or PUI, an oil platform, and we could tell them that they are missing a particular item for that project because of the unit that's there and the RFID tags that we're viewing. In terms, I listened to the EMA presentation, which was good, but one thing was missing, which was we could assist with continuous monitoring. So, and we have it for water and water for quality or for basic inputs, for air pollution, particles, O2, excess carbon dioxide. And the difference here is the old tradition is you would have gone to and collect data from loggers. A little bit more modern will be telemetry units use GPRS to send that data, and you log the data. So picture something sort of a dashboard, and you're looking constantly to see in the industrial estate which are the companies that, and what are the levels of particles in the atmosphere based on which company it is, so that you could take a quicker approach to solving pollution trends. So you could say for over the last month, it's really intolerable, in terms of the amount of emissions, and instead of doing it such as using sampling methods. That's into our continuous monitoring. In some of the tools we use to make this happen, we are very, very open in terms of that, and we assist. We use Haloop, and what that allows us to do is, it's basically you get 10 to 8 times faster than your traditional relationship database management systems. And the reason for this is you could use a number of low-cost machines, which we purchase in the cloud, spots using Amazon, and we're able to send jobs to those machines to give us, so being a small company allows us to have a very heavy impact in terms of our processing power, which we buy when it's actually needed. You'll have appreciation that we use OpenStreets, I've mentioned already, which we contribute to it, and we also use nightly divs. So the nightly divs gives us updates from the community, some of you guys also to improve that data set. Postgres in the post-GIS 2, Nominatum to help us with some of our visual coding, OpenCV for open computer vision, and some tools for conversion from one form to the next. Just to give the team how it is, how a small company could address a big problem using open tools that are freely available. Okay? We see a lot of areas for improvements. Great opportunities that we see new financial regulations being placed with the FIU, with units, and a lot of data is being driven, and the address is the key thing here. And we're already at a stage where we could, from address, convert to coordinates and georeference it automatically. So you could have association or link transactions in terms of financial transactions. We see that as a user opportunity. We see improvements in the crime database and also to probably even making the data publicly available, making the sets open for research in other industries or in other areas of study. Improvements in terms of continuous monitoring with DMA, one mention. We see integration of key land management agencies. I know there was an attempt to do this. I would mark it as partially failed, but again, we probably should look at how the land registry could talk to the lands and surveys, could talk to have a common data set among to represent land in the country. See a lot of things here. We are Planet Labs, that's planetlabs.com. It's another very young company on the global startup. They are taking daily images of the entire globe and making it available. So the data set is, just imagine what the possibilities if you have an image of the entire world on a daily basis. Think things like land use monitoring with just some analytical tools as OpenCS to be able to do probably some of the things that the previous presenters mentioned. Then you could look at squatter monitoring without even having access to probably a drone or a very expensive drone. You could propose and be very analytical in the tools. So we see a lot of opportunities. We're happy, we're excited about this, and happy to be part of the program. Thank you very much.